No wieners, they're getting me.
Okay, so everything we do is eventually available on BioniChaos.com. Go check it out. Someone was asking a question. Mios on Blue Sky. So we're talking about this simulation tool for the neck. Interactive simulation demonstrates biomedical concept of a smartphone neck or text neck. It's when you're holding your smartphone for too long in your hand, looking at it. But someone was asking, building the simulation is cool, but the bit that got me thinking, do people's actual neck angles match what the physics predict? Would be interesting to let users log their own posture data over time and compare. Well, the physics, and that's normally how it works, is based on real data. So in this case, it's actually based on a paper. So if you actually if you actually looked at the text overview of the simulation, you will realize that yeah, it's based on data from a paper. So I'm not gonna go over the paper, well, because we yet don't do things like that. I mean, it just will be boring, I think. But yeah, I don't know where the model came from. But it is safe to assume that we have physics models, good physics models that are based on real data. So yes, people did log, or scientists measured posture over time, and that's the model of it. I don't know how to explain it in a better way. Probably a bot, one of the bots will be able to do it. Can talk to perhaps, which one should we talk to? And let's do Grok. Yeah, we don't like them normally. They are too verbose, so I'm talking too much. We could, however, just give them the link to the page. Just say, hey, can you review this page real quick? And then we have a few questions about where the data came from. So pop it into Grok. Interactive educational smartphone neck simulation, text name, blah, blah, blah. Should we? Yeah, I'll just read the text out loud. Use the text to speech and comment along. Wait, I have to actually. Yeah, if you have any questions, especially if you visited the website and stuff and you have any questions, I'm more than happy to take any questions. Okay, we'll do this overview and comment along.
The page at BioniChaos.com is an interactive educational tool called Smartphone Neck Simulation, also referred to as Text Neck. It's not selling any product, it's a free browser-based visualization demo built by BioniChaos, a platform focused on open biomedical data tools, simulations, and educational resources for things.
Yeah, so obviously we didn't build it ourselves. We had a bunch of AI tools building it for us, but that's okay.
The page at BioniChaos.com is an interactive educational tool called Smartphone Neck Simulation, also referred to as Text Neck. It's not selling any product, it's a free browser-based visualization demo built by BioniChaos, a platform focused on open biomedical data tools, simulations, and educational resources for things like neuroscience, biomechanics, and health tech. The core idea is to show how tilting your head forward, like when staring at a phone, dramatically increases the effective mechanical load on your cervical spine neck muscles. It uses a simple interactive slider.
Yeah, so it's showing how you just holding the phone on a certain angle, putting load onto your spine. That's what the simulation is about.
For head angle, from 0 degrees neutral up to steeper tilts, with visual feedback, a figure whose head tilts as you adjust, a growing, reddening weight icon on the head representing increasing force. Color changes.
Yeah, so essentially it has like a weight on the head of that model, indicating what's the equivalent strain put on your spine.
Green, red, in the neck area, force arrows, stress radiations, and thickening spine lines to indicate strain. Optional sonification, sound that gets more intense with higher load, and a demo play button. Key data point highlighted. At neutral position, 0 degrees, per now 4 to 5 kilograms effective load on the neck, normal head weight. At around 60 degrees forward tilt, up to 27 kilograms, 60 pounds of force, compared to the weight of an average 7-year-old child sitting on your head. This is directly attributed to a 2014 study, paper by K.K. Hansraj, likely assessment of stresses in the cervical spine caused by posture and position of the head, published in Surgical Technology International. It's one of the most widely cited and popularized references on text neck biomechanics. You'll see that exact 60 pounds, 27 kilograms figure repeated across health sites, posture articles, and even some chiropractic physio content. The simulation appears to model load values consistent with that paper's simplified lever arm calculations, treating the head as a cantilevered mass with increasing moment arm as tilt increases. No other data sources, studies, or references are listed on the page itself. No external links to the Hansraj paper, no additional citations, no raw datasets, and no claims of original research by BioniChaos. It's presented as an illustrative teaching tool rather than rigorous scientific software. There's also a short section with basic counter exercises.
Well, so the point of that is that most people don't read papers, and that's unfortunate because it must be a great paper. Well, I haven't read it myself, but what we did is we loaded the data from the paper into one of the AI tools and generated this web application That is, if you stop the demo, you can interact with it yourself. I don't know what's up with the text there, but and it will show you the stress level onto your spine. And yeah, the data is coming from a paper. So supposedly the physics are based on real recordings, real data and stuff. Yeah, so if you have any, especially if you visited the site and you have any questions about it. Yeah, so the original question was, yeah, building the simulation is cool, but the bit that got me thinking, do people's actual neck angles match what the physics predicts? Yes, so that question is it's a bit weird because, yeah, normally physics will be defined by, you know, real measurement, real world measurement. So yes, so it would be interesting to let user log their own posture data over time and compare. Well, that was already done. So there you go. One sec. Yeah, someone was asking what software do we use. So yeah, it's obviously mostly JavaScript because we're trying to make it available for you to use. If we had it in Python, normally we start with Python, but then, you know, it doesn't have to be complicated. We're trying to simplify things. So eventually, if we're able to convert it into JavaScript, it's much better. First of all, because I can share it. Second, it's more simple, so on and so forth. Yes, so where were we? Yeah, we were doing this summary by Grok, I think. So keep commenting on that. Listening to the text-to-speech.
Sizes, chin tucks, neck tilts, shoulder blade squeezes, and a standard disclaimer. Stop if painful and consult a professional. Overall vibe, purely educational, awareness raising.
Yeah, purely educational.
Not commercial or biohacking salesy. BioniChaos seems to be a solo small dev project with YouTube live streams, Reddit posts, Patreon, GitHub, creating free open browser tools. They've done videos walking through building, debugging this exact neck sim using AI assistants, e.g., Grok, Gemini for code help, and people have reacted positively to it as a clear visual aid. What specific questions do you have about the data origins, sources, or anything else on the page?
Yeah, right. So it
Fire
gave
away.
us a general overview, which is fine. But yeah. Yeah, so essentially I want to know how to improve this tool, make it any better. If you have any suggestions, go for it. But yes, the data is based on, the physics of this simulation are based on real data. Yeah, I have trouble connecting to the voice model, so we'll have to use dictation. Yeah, so this is a model we developed, so it's on our website. Yeah, so essentially we gave one of the coding tools the paper, turn it into a requirements document, generated the code, the simulation based on it, and this is the result. Now the question is, yeah, how do we go from there in terms of making it better, looking more realistic, perhaps? What do you think? Transcribing. Let's see what it says. Yeah, it's a simplified, highly simplified 3JS thingy. There is kind of not much to it at the moment. Yeah, to begin with, we didn't have the hand, so we had to add the line for the hand. Yeah, now we have it, but it doesn't mean it's much better. Okay, so we're having Grok like giving a few recommendations, but I'm not sure if they are specific. Obviously, I don't think it looked at the code or anything, but we will read it out loud, text to speech, whatever, comment along.
Awesome. Congrats on building this. Turning the Hansraj 2014
Awesome.
paper into a
Congrats on
live web
building
sim
this.
via an AI coding tool is exactly the spirit of what BioniChaos does.
Yeah, that's exactly what we're doing. Taking papers, turning them into interactive web simulations. That's right.
The original paper itself used a finite element model in CosmosWorks, a desktop engineering package with a simplified cantilever setup, around 6 kilograms head plus neck mass, center of mass around 16 centimeters above sea level.
Okay, so maybe I was wrong at actually using like a simulation. But I mean the simulation, yeah, so it's not using real data. So the physics of the neck and the head and stuff and how much weight it puts on your spine when holding the phone is probably, yeah, based on this simulation, like a physics simulation. But the physics simulation then was made using some real measurements. Pretty sure. Yeah, if you check the simulation yourself and you have any questions, do let me know. We'll keep listening to the overview.
Then calculated moment arm growth with forward tilt. You basically replicated that math in the browser. Super smart and effective for awareness. The current version nails the wow factor. That 27 kilogram 7-year-old child visual at 60 degrees hits hard. But yeah, it still feels a bit 2D cartoon and static. Here's a realistic phased roadmap to level it up.
Yeah, it's definitely too static. The simulation is too simple. Yeah, we could definitely improve it. I mean, we would not be doing it ourselves. We'll need some help.
Up without losing the simple educational vibe. I've broken it into quick wins, days, weeks, and bigger realism upgrades, weeks, months, based on the actual limitations of the Hansraj model. It ignores muscle damping, multi-segment spine, shear forces, and real-world angles are rarely 30-35 degrees, per newer kinematic studies. Quick wins. Keep it lightweight, still plain JS canvas.
Yeah, we do want to keep it lightweight, that's for sure.
1. Better visuals without new libraries. 2. Replace the cartoon figure with a cleaner SVG-based spine. Use paths for individual C1 to C7 vertebrae plus discs. Make the cervical curve dynamic.
Yeah, that will make it unnecessarily more complex. I don't know what. Why would we add like a more detailed model of the spine? Not sure about that.
Flatten as angle increases. That instantly looks more anatomical. 3. Add subtle muscle overlays, trapezius, SCM, scalenes, that thicken and go from green, orange, red. Super cheap with CSS filters or canvas drawing. Upgrade the math. Stop using a static table. Implement the actual torque formula from the paper. Force equals head weight times cosine theta plus moment arm growth times sin theta. Let users input their own head weight, default 4.5 to 5.5 kilograms, and show both effective load and estimated disc compression shear. Simple multipliers from later FE papers. Add a second line on the graph, realistic daily angle. Most studies show 20 to 30 degrees average during phone use, not 60 degrees. Sonification plus feedback polish. Make the sound pitch shift based on real-time torque, web audio API oscillator, instead of just volume. Add a cumulative load counter. 2 hours at this angle equals X.
Yeah, the sonification is pretty basic. It's just as the a single sinusoid and the frequency is mapped to the angle. So nothing fancy there and not very useful. Is it?
Extra kilograms hours on your neck today. Bigger realism upgrades. This is where it feels pro. Go 3D, the single biggest realism jump. Switch the core
3D.
renderer to 3JS or Babylon.js if you want easier physics. 5. Load a free GlueTF cervical spine model, plenty on Sketchfab or from OpenSim exports. Animate each vertebra segment individually so the whole neck curves naturally, not one rigid head tilt. 7. Add rotatable camera plus side-by-side neutral versus text neck view. This is still browser-friendly.
Yeah, it got all the ideas, but yeah, we either have to go bottom up where we, take this one, develop it, or we redevelop it from scratch. Yeah, if there is a model, well, the model will have to be public domain. If there is a model we can use, that would be absolutely amazing. Surely Grok should be able to just generate the code for us. That would be nice.
And runs at 60 FPS on phones. Add real muscle and multi-body physics. Pull in simplified OpenSim style muscle data. There are free neck musculoskeletal models on simtk.org. Show estimated muscle forces, not just passive weight. Use a light 2D physics lib like matter.
Yeah, so currently we don't have any muscles in there, right? So it's just essentially just showing you weight on the spine based on the angle. So we have to also stick to what's available in the paper. That's the other thing. Can you actually find that paper and make the response more grounded based on what's available, what data available in the paper, so we don't have to overcomplicate things? We're only basing this simulation on that one paper. I don't know if it will be able to find it, or do I need to load it as a PDF or something? Yeah, it's actually pulled the paper. I have to go with it. I'm not gonna read it myself.
Perfect. I pulled the exact 2014 Hans Raj paper, the one your AI coding tool was based on. It's a short 3-page article, Assessment of Stresses in the Cervical Spine Caused by Posture and Position of the Head, by Kenneth K. Hansraj, Med published, in Surgical Technology International XXV, Ps 277 to 279. Here's the direct free PDF, no login, paywall, pingep.pry.ee. Other mirrors exist, but this one is clean and complete. Exact data from the paper, verbatim, this is all there is. Model used. A model of the cervical spine was created with realistic values in CosmosWorks, a finite element assessment package. Calculations were made and then forces were extracted in newtons.
Right, so it will be interesting to see if that CosmosWorks has like a JavaScript version of it, or if we can, take that model and convert it into JavaScript so we can display and play with it on the website without, because that's what they used in the paper. I'm not sure if it's actually publicly available. Can we actually check if the CosmosWorks, first of all, if it's publicly available, and also if it has a JavaScript version? Or third question will be if we can convert it into JavaScript, that specific model, using CosmosWorks somehow, or not, maybe. Yeah, so we'll leave it as, we'll keep listening
And then
to
convert it into pounds. We made the calculations using neck plus head, which gave an average weight.
Yeah, there's a kilogram to pounds conversion. Obviously, not gonna
Of 60
deal with
newtons, 6 kilograms, or 13.2 pounds. The center of mass was located 16 centimeters above C7, or 15 centimeters from the top of the skull. Results table, figure 1. This is literally the only data point in the entire paper.
Right. Yeah, I didn't realize it was a while back, but essentially we just turned this literally only one data point. Well, it's not one. It has this table. So yeah, position and force on cervical spine. And yes, the center of mass was located 16 centimeters above C7, or 15 centimeters from the top of the skull. Okay, that's kind of important. It could be used in a simulation in a clearer way. Currently, it's not there. But essentially, the table has a position, neutral, and then 15, 30, 45, 60, 90 degrees angle for holding your phone, and how much force it puts on the cervical spine. So that's the data that we are basing this our simulation on. And yeah, and this came from this CosmosWorks, a finite element assessment package, whatever that is. Wonder if we can convert it into JavaScript somehow. Well, essentially that's what we did, but I'm not sure how accurate it is.
You can look at the table in the conversation history. The paper says, an adult head weighs 10 to 12 pounds in the neutral position. As the head tilts forward, the forces seen by the neck surges to 27 pounds at 15 degrees, 40 pounds at 30 degrees, 49 pounds at 45 degrees, and 60 pounds at 60 degrees. No equations, no formulas, no raw code, no muscle damping curves. Just these 6 numbers extracted from the CosmosWorks model. Explicit limitations, verbatim. We are aware that the muscles, tendons, and ligaments dampen the stresses seen by the cervical spine. For our assessments, the calculations of the stresses seen by the neck are for the neck and muscles, including ligaments and tendons. At 90 degrees, the model broke down. That's literally it. Your current sim is already spot on. Neutral 4 to 5 kilograms, about 10 to 12 pounds head weight, and 27 kilograms, 60 pounds at 60 degrees, matches the paper exactly. They just use the 13.2-pound neck plus head total for the internal calc. How to make the sim better while staying 100% grounded in this one paper. No need for 3D, open sim muscles, web...
Yeah, yeah, we definitely don't need 3D. What
cam
else?
tracking, shear forces, or later studies. Those would take it outside the paper. Keep it dead simple like Hansraj did. Here are the small...
Yeah, there's obviously going to be lots of relevant studies, but we're not going to look at those. Just focus on this one.
highest impact tweaks that make it feel more official and educational. 1. Hard code the exact table values instead of any interpolation or extra math. Just use these 6 points.
Yeah, I don't think... yeah, so we're doing interpolation in this simulation. It's recommending just using exactly the 6 points and the slide to snap. I think that's what it does. Wait, if we stop demo... no, it does do interpolation. Well, what's wrong? What's wrong with the interpolation? I mean, it's pretty linear. I'm not sure what's wrong with the interpolation. Like, I mean, it's pretty linear data anyway. So the interpolation should be fine, shouldn't it?
Slider snap to 0 degrees, 15 degrees, 30 degrees, 45 degrees, 60 degrees, and caps at 60 degrees since 90 degrees is not measurable. Display the exact pounds and kilograms side by side. Paper uses pounds, but your kilogram version is fine. Add a tiny kilogram version is fine.
Yeah, so we have the... Yeah, it's the slider stopping is going all the way from 0 to 60. Yeah, it's not going above 60, which is what the paper indicated, so that should be fine. I still don't see a problem with the interpolation, so the interpolation should be okay. I think it's fairly linear anyway. I mean, we can plot it, but I'm not sure if there is a need for that.
Tiny matches Hansraj 2014 label. 2. Show the paper's own figure 1 right next to the sim a static screenshot
Yeah, we're not gonna
or simple
show
bar graph
the
of the table
paper.
above the interactive slider. User
Yeah, we're not gonna show the graph from the paper. That's for sure. Well, that's why we're turning it into a simulation.
instantly see your current angle equals exactly what the paper measured. 3. Use the paper's exact inputs. 4. Default head plus neck weight equals 13.2 pounds per 6 kilograms. Let users tweak it slightly if they want.
I didn't finish reading the whole thing. We can comment on the rest. Yeah, maybe showing the center of mass is kind of important for the simulation. What do you think? I'm not sure. Yeah, and eventually we'll turn them into Eventually, we will turn all this conversation information into instructions for the developer. But yeah, we'll do it later. So it's not a single shot thing. Yeah, the Cosmos Works is not publicly available, so
CosmosWorks, now long rebranded and integrated, is not publicly available as a standalone free download or open tool. It was the FEA, Finite Element Analysis add-in for older SolidWorks versions, roughly up to SolidWorks 2010 to 2012 era, then renamed to SolidWorks Simulation, still the current name in 2025 to 2026.
yeah, so it's SolidWorks. Yeah, it's a commercial package. We're not gonna touch it or anything, but essentially that's what we're doing in JavaScript. Essentially, we're showing how AI can turn, well, any data points into an interactive simulation similar to SolidWorks. Yes, essentially for free, as opposed to paying SolidWorks an arm and a leg.
No free, public version exists for the original CosmosWorks. It's always been commercial, tied to SolidWorks licenses, which require paid subscriptions or educational access. SolidWorks Simulation, the modern successor, has trial options, student educator community downloads,
Yeah, we're not
restricted
gonna go
to qualified
there.
users, often emailed after verification,
We're not
or
gonna get the
maker
license or
hobbyist
anything.
tiers like SolidWorks for Makers. $48 a year, but limited features and not full FEA export. Nothing open source or browser-based for the exact 2014 Hansraj era CosmosWorks setup. No JavaScript web browser version of CosmosWorks ever existed. It was, and is, a desktop Windows plugin for SolidWorks CAD. No ports, no WebAssembly equivalents, nothing official. Converting the specific Hansraj model from CosmosWorks to JavaScript, not feasible directly. The paper doesn't provide. The actual CosmosWorks project file, .sldprt, .sldasm, mesh settings, material props, boundary conditions, etc. Any equations beyond the basic setup description. Head plus neck, roughly 6 kilograms, 60 north total mass, coam 16 centimeters, above C7. Mesh details, element types, solver outputs, or validation steps. Hansraj ran a proprietary desktop FEA sim once, extracted 6 discrete data points, the table, and published only those. There's no model file floating around publicly to import, convert. It's not like an opensim.osim file you can export. You'd have to reverse engineer, rebuild the entire thing from scratch in JS, which is what your current sim already approximates, via interpolation or curve fitting those 6 points. On interpolation, you're right, it's fine, and probably better for a smooth slider. The paper's data is discrete, 0 degrees, 15 degrees, 30 degrees, 45 degrees, 60 degrees, but the underlying physics is a lever arm moment increase that's roughly nonlinear. Force grows faster than linear with angle due to sine theta or similar in torque calcs. But let's look at the numbers. 0 degrees, 10 to 12 pounds per 5 kilograms. 15 degrees, 27 pounds per 12.2 kilograms. Big jump already. 30 degrees, 40 pounds per 18.1 kilograms. 45 degrees, 49 pounds per 22.2 kilograms. 60 degrees, 60 pounds per 27.2 kilograms. If you plot pounds versus degrees, from 0 to 15 degrees, 1.1 pounds per degree. From 30 degrees, 1.1 pounds per degree. From 30 to 30 degrees, 1.87 pounds per degree. 30 to 45 degrees, 1.6 pounds per degree. 45 to 60 degrees, 1.73 pounds per degree. It's not perfectly linear, steeper at low angles, then flattens a bit. But for a browser slider, smooth, continuous feel, linear interpolation between points, or even a simple quadratic fit works great and avoids weird jumps. Snapping only to the 5 angles would feel clunky for users dragging the slider. Your current smooth version from 0 to 60 degrees is educational and user-friendly. No real problem with it. The paper never claimed continuous values. It just sampled at those increments. If you want to be extra faithful without overcomplicating, keep smooth interpolation. Add small text labels at the snap points or hover tooltips showing the exact paper values. At 30 degrees, 40 pounds per Hansraj 2014. Cap at 60 degrees, as you already do, and gray out. Note, beyond 60 degrees, model not reliable, per paper. Center of mass visualization, yes, worth adding, keeps it grounded. The paper explicitly calls out center of mass located 16 centimeters above C7 and 12 centimeters from top of skull in one spot. Showing this visually reinforces why the force explodes with tilt, its basic lever physics. Simple ways to add it, still 2D, canvas, no new libs. Draw a small dot or crosshair, roughly 16 centimeters up from the C7 pivot point on the figure spine. Label it AM, 16 centimeters above.
Okay, I'm not sure if we need to change the simulation for that, for adding the center of mass. I'm not sure if the simulation will be better. I think we do describe it in the text below the simulation already. Do we? We need to check. Yeah, so we'll probably go for one or the other. Instead of changing the actual simulation, we might just pop that explanation in the chat. No, it's actually not in the, sorry, in the chat, in the text. So yeah, it's not in the text at the moment, so probably have to add it there. And what else we've got?
C7, Hansrad 2014. As head tilts, draw a dash line from C7 pivot to AM to show the growing horizontal moment arm, the real culprit. Optional, tiny force arrow at AM, perpendicular to the line, scaling with angle. This adds educational value.
Yeah, I don't really get it. Like, would it really add an educational value without complexity? Adding the center of mass? I can't picture it. Like, how would it look like? Just thinking it will just add the complexity to the simulation. That might be unnecessary.
Value without complexity. Users see why 60 degrees equals 60 pounds, longer lever. Not just accept value without complexity. Users see why 60 degrees, 60 pounds, longer lever, not just accept the number. Your current approach, smooth slider 0 to 60 degrees, interpolated loads, no graph from paper, is solid for what it is. A quick, browser-based awareness tool, faithfully based on the one paper's outputs. No need to force discrete steps or hunt impossible CosmosWorks ports. If you want, drop the current interpolation formula you're using. Example, linear between points, quadratic fit, and I can suggest a tiny tweak to hug the paper points even closer while staying smooth. Or sketch simple canvas code for the koan line dot. Just let me know what part to zoom in on next for the dev instructions.
Yeah, so that's normally what happens is that you have this paper is in the public domain, but the data obviously, well, just a few data points. So they are part of the paper. So there's no data set or no extra data set. And then the original model that produced the data points is proprietary. So we don't have access to that. And that's essentially what we're trying to replicate. So maybe we can just do a summary of the whole thing, of the whole discussion, and start. Next will be generating instructions for the developer as to how to make it better.
Yeah, you're spot on. The current setup is already a clean, faithful replication of the Hansraj paper's key outputs, those 6 discrete force points, from neutral to 60 degrees, using smooth interpolation for a nice, draggable slider feel. No public dataset beyond the paper's table, and the original Cosmos Works model is proprietary, closed, desktop SolidWorks plugin from 2014 era. No exportable file or JS port possible without rebuilding from scratch. Your sim effectively does what the paper did, shows the dramatic load increase based on those sampled angles. From checking the live page, BioniChaos.com, it does not currently mention center of mass, 16 centimeters above C7, or any lever arm explanation in the visible text. The explanatory copy focuses on the interactive demo, the effective load display, 4 to 5 kilograms neutral to up to 27 kilograms at 60 degrees, visual cues, color changes, growing weight icon, force arrows, stress radiations, the Hansraj 2014 reference with the 60 pounds, 7-year-old child analogy, basic posture advice, and the short exercises list, chin tucks, neck tilts, shoulder squeezes. Disclaimer is minimal. If you experience pain, stop immediately and consult a healthcare professional. No deeper physics, like moment arms or why the force multiplies. So, adding the center of mass, COM, explanation would be low effort, high-value, text-only tweak. No need to touch the simulation code, visuals at all, if it feels like unnecessary complexity. Why it adds educational value, without complexity. The paper's core insight isn't just force goes up with angle, it's lever physics. As the head tilts forward, the horizontal distance, moment arm, from the neck pivot, C7, to the head's comb grows, multiplying the torque load like a seesaw. The 16 centimeters above C7 is the key setup detail Hansraj used for the model. Mentioning it helps users intuitively get why 60 degrees quickly 5 to 6 times the neutral load, not just memorizing numbers. How it could look in text, simple paragraph to drop below the slider or in the description. Why does the load increase so much? It's basic lever physics. In a neutral position, your head center of mass, COM, sits roughly aligned over the neck base, C7 vertebra. As you tilt forward, the COM shifts farther ahead horizontally, creating a longer lever arm. The paper's model placed the COM about 16 centimeters above C7 in neutral, the same distance used here. Tilting stretches that arm, so the effective force on your cervical spine multiplies dramatically, per Hansraj 2014. Users who care about the why will appreciate it. Casual viewers still get the wow from the numbers, visuals. Keeps everything 100% grounded in the one paper, verbatim from Hansraj. The center of mass was located 16 centimeters above C7. If even that feels like too much, just add a tiny footnote or tooltip on the load number. Based on a model with head, neck, COM 16 centimeters above C7, Hansraj 2014. Quick summary of our whole discussion so far. The sim faithfully replicates Hansraj 2014's table, neutral 10 to 12 pounds, roughly 4 to 5 kilograms, up to 60 pounds, roughly 27 kilograms at 60 degrees. Interpolation is fine, good for UX. Data isn't perfectly linear, but smooth feels natural and educational. No need to snap to discrete points. No access to the original Cosmos Works model. Proprietary, no JS version, no public file. Current page text credits Hansraj, but doesn't explain the lever COM mechanism. Best low complexity upgrade. Add 1 to 2 sentences in the explanatory text about the center of mass, lever arm. Helps understanding without code changes. Avoid 3D, muscles, webcam, shear forces, etc. Stay true to the single paper's scope. Disclaimers, exercises are already solid. Could echo the paper's muscle damping note if wanted. Muscles, tendons, ligaments help dampen these forces in real life. Ready for developer instructions? We can package this into clear, prioritized dev tasks next. Something like, Priority 1, quick text polish, no code risk. Add paragraph, footnote, explaining center of mass, 16 centimeters above C7, and lever arm effect, citing Hansraj verbatim where possible. Optional, hover tooltip on load value, showing exact paper pounds at nearest angle. Priority 2, If want minor sim tweaks, ensure slider caps at 60 degrees, with note, beyond 60 degrees, not reliable per model. Add small labels, tooltips at 15 degrees, 30 degrees, 45 degrees, 60 degrees, showing exact paper forces, pounds per kilogram. Priority 3, Polish accessibility. Strengthen disclaimer with paper's damping note. Any minor visual tweaks, e.g., make weight icon scale more dramatically. Let me know if that captures it, or if you want to tweak, add anything before we finalize the instructions list for the dev.
Well, did evaluation locally with Python.
Here's a standalone conversational set of notes, instructions you can send directly to the developer. It keeps things light, asks questions to get their input, makes gentle suggestions, and avoids any technical do this exact thing directives. Feel free to copy, paste, or tweak it as needed. Hey, hope you're doing well. We've been chatting about the smartphone neck text neck sim on bionichaos.com/neck/neck, and I wanted to share some thoughts and questions to help guide the next little polish round. Nothing major, just making it feel even more educational and trustworthy while staying super true to the Hansraj 2014 paper it's based on. Quick recap of where we're at. You already know most of this, but just for context. The sim does a great job showing the load jump from 4 to 5 kilograms neutral to 27 kilograms at 60 degrees. Matches the paper's numbers perfectly. Smooth slider from 0 to 60 degrees feels nice and intuitive. Capping at 60 degrees is spot on since the paper stops there. We're crediting Hansraj and using the 7-year-old child analogy, which people seem to love. No need to chase 3D, muscles, webcam tracking, or anything fancy. We want to keep it lightweight and faithful to this one study. A few open questions and gentle ideas we'd love your thoughts on. 1. Explaining the why a bit more. The paper mentions the center of mass being about 16 centimeters above C7, and that's basically why the force multiplies so dramatically. Longer lever arm as the head tilts. Right now, the page doesn't explain that lever physics bit at all. Do you think adding a short, plain English sentence or two in the text below the slider, or as a little tooltip, hover, would help people get it better? Something like, it's lever physics. Tilting your head moves the center of mass farther forward, multiplying the load on your neck. Would that feel like useful context without cluttering things? Or do you reckon it's better left out to keep the focus purely on the numbers visuals? 2. Showing the exact paper numbers at key angles. The paper only gives forces at 0 degrees, 15 degrees, 30 degrees, 45 degrees, 60 degrees. Our smooth interpolation is working well for dragging, but maybe we could quietly reinforce trust by showing the original pounds values at those exact points, e.g., tiny label or tooltip that pops up. At 30 degrees, 40 pounds per Hansraj 2014. What do you think? Would that make the sim feel more official and grounded, or would it distract from the smooth experience? 3. Strengthening the real-world caveats. Hansraj himself notes that muscles, tendons, and ligaments dampen these forces in real life. We don't model that. The current disclaimer is solid, but pretty general. Would it make sense to echo his wording a tiny bit more closely in the footer or disclaimer pop-up? Just to be extra clear, this is an educational illustration, not a precise personal diagnosis. Any thoughts on phrasing that would feel natural? 4. General vibe check. Overall, do you feel like the sim already communicates the core message really clearly? Or are there any small wording, layout, or visual tweaks you've been thinking about that could make the aha moment even stronger without adding complexity? No rush, just bouncing ideas around. Whatever direction feels right to you is great. We trust your sense of what keeps it clean, fast, and impactful for people visiting the page. Let me know your thoughts whenever you have a moment. Cheers.
Okay, so if you have any questions about the website BioniChaos.com, so everything we do on this live stream is ending up on BioniChaos.com. If you check the site and you have any questions, suggestions, recommendations, complaints, whatever it is, do let me know. We'll happy to cover it during the streams. Currently we're trying to improve this neck smartphone load on your spine simulation.
Replacing 11 lines with 12 lines in. Done. I've added the explanation as a new paragraph in the web app overview section, right after the existing text and before the other sections. This keeps it near the simulation for context while placing it at the bottom of the main content area. The page should now include that plain English insight to help users understand the underlying physics. Made changes.
Yes, so we have a comment, possibly segregate the model for each individual vertebrae, as well as skeletal structure, each bound segment connecting to each other with a mathematical node that indicates the position. So yeah, for this specific simulation, we're just relying it on based on this single paper, apparently just a 3-page paper that only had the single table with the loads, and that was based on a model from, yeah, like a physics model of some sort. So we're just kind of sticking for to that to those 6 data points in the paper. So that's pretty much it. So yeah, so if we're doing something else, I assume it will require separate simulation or something.